Good afternoon, gentlemen. My name is Ferdinand Chukwu, instrumentation engineer for Jumod. Today, we want to do exposition on one of our geological instruments by name SK2NO1G Mudstone density meter. This instrument is used for measurement of density, used for measurement of mudstone density or shale cuttings, only shale cuttings. So I just want to do a brief explanation. We have the graphical drawing of this equipment on this board, as you can see. We can quickly go over the features. Here you can see the tray, small tray. You can see the graduated scale in the mirror. Then zero position adjustment. You can see how we adjust it. Then also we have this big tray here on top of the floater, fixing mirror bracket. Then the floater, stainless steel pole, and the water inside this glass. So these all the graphical values are. You can see from this one also the real one. This mudstone density kit is in every mud logging unit. You can see we have this equipment here, mudstone density meter. That is how it is. So it comes like this. It comes like this, and in every unit you can have it. So we just have to open this up, and you get the meter here. So just today we just want to know how we can put this meter to use. You can see all what we discuss here in the graphical picture here. We can see it here. See the mirror and the scale divisions. You can see it there from 0 to 160. Then you can see this is the bracket. Also you can see the adjustment mirror. Then this is your floater. This is the floater. This is the small tray. This is the floater itself. And this is the big tray. Here is your damping hammer. So usually this thing goes in like this. So quickly we have to inject what we want to do here. We'll quickly do that while it sets up this. We'll talk more about this. Technical indicators. Measuring range should be 1 to 3 grams per cm cube. We don't measure anything above this. Minimum sample weight is 0.05 gram. Resolution is 0.03 gram per cm cube. Operations. For this measurement, we use pure mudstone, mudstone, free of any other substances, free from sandstone, sand, whatever you have, limestone, and any other debris. You have to be free from it. Then you ensure that the sample is angular and is also indurated. That means it does not wet. It's very solid, so it's competent enough. So we allow this. We carefully blot up the surface. If you get the sample, just clean with any material. You just clean. If you have a filter paper, it's better. So you clean that. You clean the sample and you keep it ready for use. Then make sure you don't heat it during the cleaning. Don't heat. Add several drops of detergent. Please, you add several drops of detergent here. You add it here. You add just some drop. Then you inject water into it. You inject water into it. You follow the procedure. When you inject water into this, you ensure that the water level is about 4 cm from the top. Please, we just watch closely. Ensure that your water, you can use any water, please. Anytime you are doing this, you can use any water, just any water, but so long it's not salty water. So when you get to 4 cm, please monitor the foam and make sure that the foam is not disturbing the region. So once you clear that foam, then you can we just have to clear the foam so that it don't disturb the. So we are putting we added that detergent for lubrication purposes. So and also to ensure clarity and clinging of water clinging on the glass. So that's why we added that. So after now we add this. When it is clear, we ensure that the water level is around 4 cm. okay. It's around the 4 cm. You can add a little, right? Okay, so it's about 4 cm from the top. Please look at it. If it's not, you can adjust whatever. You can adjust this thing to ensure that you get that 4 cm. That is it. So this is it. So you get your 4 cm correct. Then what next? You put this floater in it. When you put the floater and you allow the floater to dip to the bottom, you see the hammer is touching the bottom now. It must not be more than 2 cm. It must not be more than 2 cm from the top after dipping the floater. So you can see we're having about 1 point something cm, which is very okay. So this is what you must have before you start the measurement. So you allow it to come to rest. So part of what this thing we do here, after adding that detergent and cleaning, we inject water into the glass as we discussed. Now we inside the floater and all that. So ensure all that. So adjust for zero position. Once we are done with this guy, we must go for zero adjustment. You know, right now the floater is there about 1 cm. So we want to zero the position of the floater, that is top of this tray, so that it will be zero. So if it's not zero, you can move the bracket. You can move this bracket downwards so that you can get the zero you want. Once it's at zero, you hold it. So now with the essence of making it zero is such that when you start taking your measurement, the measurement is actually coming from zero, not from any other value. But if you have that value, you still want to use it, you can use that value as your zero, but we just zero for consistency. So now we are ready to measure the cuttings. So now we just take a simple grain, a simple cutting. This cutting is about 1 gram. We can check, plug this in and check. If it's about 1 gram, you can check. You don't need the weighing machine that much, and just for you to have an idea of what you are measuring, you can now get the value you want. Remember that one of the technical details, we said that the minimum sample weight should not be less than 0.05 gram. Should not be less than 0.05 gram. So okay, all right. So we just see like this one now. We have this small sample here we dropped, and you see it gives us it's giving us about 0.2 gram. It's giving us about 0.2 gram. You see, this small thing is giving us about 0.2 gram. That is enough for the measurement. So immediately we can introduce this to this small tray here. So once you get this, because in part of the operations we are having, after adjustment, you put the muscle sample in the small tray and observe the floater dip downward. So when it dips downward, you have to wait until it will balance off. Once it balance off, we read off the value and we allocate that value as our L1. So once you get that value, you see that it gives us about L1. So it gives us about L1. Then what do we do next? We remove the sample. We remove it and we introduce it into the bigger tray. We remove it into the bigger tray. Then we now allow it to submerge again. So when we allow it to submerge again, we now wait for it to be stable. Then we take that second reading as our L2. Once we get that L2, we will now introduce it into this formula. The density of the mudstone can be calculated as follows. Density is L1 over L1 minus L2. This is in gram per cm cube. So this is the major formula we are substituting to. So once we substitute, we get the value. So he will help us out with the calculation as we have put the value. So once we get that value, the whole measurement is finished. So everything we are doing here is very okay now. The density value will now be the values you will calculate from there. From our readings, L1 is 6.5, L2 is 3.6. So when we substitute, we have L1 over L1 minus L2. That is 6.5 over 6.5 minus 3.6. This same value will give us about 6.5 over 2.9. 6.5 over 2.9 will give us about 2.44. 2.24. In that will give us the specific gravity is what we have now, 2.24 grams per cm cube. So you see, this sample we just picked now is one of the, as we are drilling 8.5, we just picked some grain of shale cuttings from the where we are drilling. So we just did this measurement now. So our aim is to record these densities accordingly as we go, and we can now compute and give to the geologist as report. So I think that is all we want to learn about this. I can quickly also tell us the advantages of this particular equipment over the what we are used to, because we are used to measuring of density with the bulk density measurement tool. So quickly we can say one of the advantages we saw is it uses a small quantity shale cuttings, less than or equals to 0.05 gram, greater than or equals to 0.05 gram, then less than or equals to 2 gram. So it should be above 0.05 gram, your cuttings. You don't really need to measure this. Once you have measured once, maybe you can see that thing is about 0.2 gram or thereabout, you just use it. Then you don't really need the weight that much. So you just continue to use that. Then you now have that shale cutting, because it's small, it can give us a lot of room to play with. Also, because of the small quantity we are using, we can measure densities on a wide range, even on formation, not necessarily 100% shale. So even as you are seeing shale, maybe shale is 40, shale is 50%, you can do your shale density measurement. Unlike the other one that you need to measure, you wait for 100% shale because you are doing bulk measurement. Okay, it is much faster, simpler, and it gives direct density value. So it's not, you don't have to give indirect. Like the other one, we measure relative density, then we now substitute to a formula to give you the density. But here you get a density value direct, so it saves time. So the aesthetics looks better than the previous type and can be used within the office area. So you don't really need to go to shaker to measure your densities. You just do it quietly in the mud logging unit. So the cuttings you are getting, you don't have to pick extra samples. You don't need to get that. It's from the samples that you are already collected that you use to do this job. So by and large, I can see that this equipment will serve us better if we can deploy it to better use. Okay, thank you guys for listening. Thank you very much. Let's go. No time to waste.